Hello everyone. In today's lecture, we'll continue studying the energy and power signal. So in last lecture, we have actually studied how to determine the signal energy and signal power, which is demonstrated with the equation 1.2b and the equation 1.3b. Okay, with these equations, we can determine the signal energy and signal power. For example, we have considered these two signals, or we are about to determine the signal energy and signal power. Signal energy for this signal and the power of this signal. Okay, so let's do it. To determine the signal of this figure demonstrated in 1.2a, here we have the signal x of t, and we can see that the x of t is 0 from minus infinity to minus 1, and then again the value of x of t is 2 until x is equals to 0. The value continues with the value 2. I mean x of t continues with the value 2 until the time is equals to 0. Remember, the whole axis is represented, the whole signal is represented with respect to the time t. Okay, after t equals to 0, signal has another shape which is demonstrated, which can be like demonstrated with this equation 2e to the power minus t by 2. This is the equation of this part. Here the x of t is equals to 2, and before minus 1 the value is 0. So this is our signal x of t. We are about to determine the energy of this signal. So we know we can determine the energy with the by integrating the whole term from minus infinity to infinity by making x of t by taking the square version of x of t. Okay, let's do it. Here Ex, we are about to determine the energy, which is represented with Ex, which is equals to minus infinity to infinity x of t whole square dt. So as long the values of this part, that means minus infinity to minus 1 is 0, therefore the 0 square will be 0. Therefore the whole integral part before minus 1, the whole integral part before minus 1, before t equals to minus 1, will be appear as 0. Therefore we didn't include that part. We will just integrate this function from minus 1 to infinity, because there exist actually the values of x3. Okay, this is what we have done here. We separated this signal into primarily three different parts, but as long this part is 0, we are just taking only this one and this one, these two parts. Okay, so here we'll integrate from t equals to minus 1 to 0, where x of t is equals to 2. This is actually done here, minus 1 to 0. See, minus 1 to 0, limit minus 1 to 0, x of t whole square, where x of t, the value of x of t is actually 2. Therefore 2 square dt. This is one part, plus will actually integrate this part also. Here the limit is t equals to 0 to infinite. Here limit 0 to infinite, 2e to the power minus 2 minus t by 2 whole square, which will appear as 4e to the power minus t, because 2 square is 4, and e to the power minus t by 2 whole square will become e to the power minus t. Therefore the function has become 4e to the power minus t. And then if we calculate this integration, we'll find out the value as 4 plus 4, which is equals to 8. That means that energy of this signal has become 8. I'm sorry. The energy of the signal in figure A is actually 8. Now let's calculate the power of power of the signal B. Okay, look at the shape of this signal. It's a sawtooth signal. It looks like a sawtooth signal, and the interesting part and the significant part of this signal, the significant observation of this signal is basically the signal is a periodic signal because signal repeats after a certain value to its original value, and it is continuing. Okay, so this is a periodic signal. We'll define the periodic signal in our later lectures, but for instance, we can consider we're not going into the detail of the properties of periodic signal. Just we know the periodic signal is such a signal which repeats after a certain value. Okay, so this is a periodic signal, and from the power equation, we know that P equals to calculate power, what we do, we actually uh, we actually integrate the signal over a period where T turns to infinite. That means we actually take the average of the energy in other way, which has been discussed in our last lecture. So how can we determine the power? To determine the power of a periodic signal, what we do, uh, take a portion, I mean the full periodic portion of any signal. What we do, we take the full periodic option. That means from this signal, you can see that from -4 to -1, signal is actually going up, then again going down, then again going up. And at -4, the signal value is 0, and again at -2, signal value has become 0 again. Then after -2, the signal is continuing the previous shape, and after 0, the signal is continuing the previous shape. This way, the signal is continuing its previous shape after a certain period of time, which is which can be determined by -4 to -4 minus -2, which is 2, right? That means the actual distance from -4 to -2 is 2. That is the period of this signal, because this is the time axis, and the after 2 unit time, the signal repeats itself, right? So to evaluate the power of the signal, what we do, we can consider any portion of the signal. We can determine the power signal from -2 to 0. We can determine the power of the signal from -4 to -2. We can determine the signal a signal power from -1 to 1, again 0 to 2, whatever. We can take any periodic duration to determine this to determine the power of the signal. Okay. Now for our calculation, we have taken from the periodic duration from -1 to 1. Okay. So with these values, we are actually determine the power. As long this is the time period here is 2, therefore to determine the power, we'll consider this capital T as 2, because our power is 2. Okay. So what we do to consider power, we actually integrate the signal square term over the period, then divide it with the periodic term, and this is the way we can determine the power of the signal. So here 2 is the period, our duration is from -1 to 1, x of t is our signal. Look, x of t is our signal. Okay, so we will take x of t whole square dt. Now look at the function of this signal. You can see this is a straight line going through the origin, so we can find the equation of this signal, and which will appear as x of t equals to t, x of t equals to t. So the function of this signal is x of t equals to t, because this is in a straight line and going through the origin. Okay, so t is the function, therefore we have taken t square here, and we evaluate this term by integrating t square from -1 to 1, and the value will come up as 1 by 3. Remember, you need to know how to integrate in a function as the integration you have learned from the differential and integral calculus course. So if you have difficulties in differentiating different terms, please go through your previous textbooks and lectures so that you can understand how to differentiate the functions. Okay, so the power of the signal x appeared at figure B is actually 1 by 3. Let's look at another examples here. Determine the power and RMS value of this signal. We'll just deal with the power. We'll deal with RMS value in our later lectures. Okay, so we'll just learn how to deal with, or how to determine the power for these functions. For example, in the equation A, we have got x of t equals to c cos of omega naught t plus theta. Okay, so how to determine the power of this function? To determine the power of this function, what we do, we take limit t tends to 0, 1 over t to the power minus half t by t half to plus t half. Okay, because this is a periodic signal. As long this is a cos signal, this is a periodic signal, and it has a period which is t, and we can determine, as we have discussed earlier, that we can take any duration of the period, to determine the power. So we have taken minus t by 2 to t by 2, which is actually the t, which is actually the demonstrate the period is actually t, because if you subtract t by 2 from plus t by 2, that means if we do t by 2 minus t by 2, you will get t. Okay, so this is actually the duration of the period. So from one point to another, we are actually integrating this actual function. The function is c cos omega naught t plus theta. So it will become c cos omega naught t plus theta whole square, which is c square cos square omega naught t plus theta dt. Okay, so you can take c square outside of the equation, because c square is a constant term and it is not dependent on the time. Therefore, we have got only cos square omega naught t plus theta dt, and cos square omega, let's consider this is as theta. That means you have got cos square theta, the whole thing, consider it as theta. Therefore, you have got cos square theta. You can determine cos square theta, 2 cos square theta with 1 plus cos twice theta. This is how you will elaborate this cos square function. That means you multiply 2 and divide 2 to equate this function, this equation. And then what you have got, 1 plus cos 2 omega naught t plus 2 theta. Okay, so if we integrate further this function, you can evaluate this. Limit t tends to 0, c square by 2t integration minus t by 2 to t by 2 dt, because 1 here is 1, therefore you have got dt plus limit t tends to 0. That means you multiply all the things with this function, and you have got limit t tends to 0, c square divided by 2t integration minus t by 2 to t by 2t by 2 cos omega t. So you know the integration of cos t is what? Well, you don't need to integrate this part because as t turns to zero, you what you have got this whole term as zero. Okay, therefore, what you will get this term as zero, and if we integrate this part, you will get capital T, and capital T and capital T will be cancelled out. Therefore, you will in the result you will get only c square by 2. So therefore, power has become c square divided by 2. You can integrate this function, but as long this is a cos function and t turns to infinity, you will get another t term over here. This will become sine omega t divided by t, and t will goes to infinity. So anything divided by infinity becomes 0. Therefore, this equation will remain as 0, and you will get c square divided by 2 as the power of this signal. Similar way, you can also evaluate the power of b. Here x of t is this function, and here you will do the similar way. You will integrate this function here. This is the function cos theta plus cos theta cos of omega 1 t plus theta 1 plus c2 cos of omega 2 t plus theta 2 whole square, right? So you can expand this equation with a plus b whole square function, which will become a square plus 2ab plus b square. So similar way, you can also determine the power of this section by of this signal by integrating these three terms. And to integrate these three terms, you can also follow the previous integration procedures. How to integrate cos square function. Here you will get two cos square functions, therefore you can evaluate these two functions. About this, you have to expand this function into this is cos a cos b. You can multiply 2 and divide 2 in this function. That means therefore you will get 2 cos a cos b, which you can express these two cos you can expand this 2 cos a cos b function into cos of a plus b plus cos of a minus b. Then you will get another expression. You have to integrate this cos of a plus b and cos of a minus b function, and this way you will get another equation which will give you the whole term as 0. Therefore, from these two terms, you will get c1 square by c2 square plus c2 square divided by c1 square by 2 plus c2 square divided by 2. This will be the power of the equation 2. You can also determine the power of this xt by also integrating this function in the similar manner. Okay, so this is how we can calculate the power of different function. Here it is given the integral solution of that c. You can also do the exercise of these problems. You can determine the energy and power of this problem, these functions. To determine the power of this function, you can consider that it is given that the equation of this function is e to the power minus t. That means the equation e to the power minus t is repeating itself by one period of time. Okay, see, from 0 to 1 it is e to the power minus t, then again 1 to 2 e to the power minus t plus minus t e to the power minus t minus 1, which is here e to the power t minus 2. This is the way the signal is repeating. These are the functions of this signal. Okay, so as long e to the power minus t function, it's a periodic x of t, x5t is a periodic function, and here x of minus t function is repeating. Therefore, as long this function is comparatively easier to find the solution, you can evaluate the energy and power of this function by integrating this signal from 0 to 1. Okay, so this is the way. This is how you can also determine the power of all these signals and signal energy of all these signals. You can practice all these problems, and you can give me your feedbacks. So thank you so much for your patience listening. I hope these problems you will do in your homework. And if you find any kind of difficulties, let me know what is actually what topics is actually is not clear to you. So thank you so much. I hope you enjoyed the lecture. Thank you so much.